Let me now invite on the stage the next keynote speaker, who is Marek Miltner. He's coming all the way from Stanford University. He's the co-founder and founder and director of the LIMESS Sustainability Lab, and he'll talk about AI and the footprint of AI and what's beyond the hype. So, Marek, the stage is yours. Welcome.
Amazing. Thank you so much. It's my pleasure being here, coming from Stanford, but also connecting Czechia with this Silicon Valley ecosystem, which is why I founded LIMESS in Prague. And I've been focused for the past 4 years researching how AI can really help us reach all of our sustainable goals. And I'm very, very happy that I've attracted such a crowd that this topic resonates, and we can explore together kind of some of the ways that we've discovered. First things first, can you imagine a world without energy? What would this conference look like? Right? Usually people say, oh, we wouldn't see because there's no lighting and it's dark outside. Sure, but it's also the heat, right? Like, we are quite comfortable here. We don't have to be in coats, even though it's winter already. But it's also, many of you have phones, taking pictures of me. These are and phones and all the electronics and even, this building is composed from very advanced materials, and especially plastics, are relying on a large network of complicated processes that are all super, resource intensive, and all of this consumes energy. And so the simple reality is that we need accessible energy, lots of it, to reach human welfare. There are no high Human Development Index countries in the world that have low electricity consumption and vice versa. And the same is if you're an economist, or you probably care about your economic welfare as well. It's a fascinating, direct, very linear relationship in terms of how accessible and how much of energy is being used in a society, and how much its participants or citizens are making. And this is true not only across a static image of the world, but also in time. So here we have 2 countries, Vietnam and South Korea, across 3 decades, and they're really following this line amazingly well. So energy is a force for good. But sadly, there are downsides. Now, again, I like to ask my audiences, how much do you think that energy is responsible for in terms of carbon emissions? And usually, we get a guess like, 5%, 30%, 50%. Well, it's over 3/4 if you include industry. So what this means is, if you want to make a difference in terms of limiting climate change or creating solutions that actually can move the needle on where the world is headed, there's no question about it. You need to be focused on energy, and that was exactly how I approached this about 4 or 5 years ago, when I decided to come back to academia and explore these topics, and found these organizations and make these networks across the Atlantic, so that we have opportunities for talented young technical people that can find solutions. But let's not just talk about the big visions. Let's talk about what is actually happening, and specifically in this context. So AI already has significant impacts on power grids. There's no question about it. There are some forecasts saying that by the year 2040, there's going to be 20% of the world's energy demand coming from data centers. You might have seen headlines in Czech news that now AI data centers are already consuming globally more energy than the Czech Republic itself. And this is definitely true, but it also presents us with very interesting connected headlines, right? Especially in the US. Now, the private sector, with big tech, including in this case Google, is investing in very highly speculative technologies that just a couple of years ago, it would be impossible to think that they would actually put their money on, including small modular reactors. with like very aggressive timelines, 2030, putting into practice. Or the most fascinating to me, and these are, by the way, all headlines from the past year. This is how current this topic is. Microsoft is now investing several $billions into a New York-based power plant called 3 Mile Island. And those of you that have heard about this, if those of you that think, I've heard this name before, it's because this particular power plant, 3 Mile Island, is famous for being basically North America's Chernobyl, right? It was the place, it was the site of the biggest nuclear accident in U.S. and North American history. So, when I imagine someone coming up now to say, okay, let's restart Chernobyl, or let's build a new nuclear power plant there, or in Asia it would be, let's put something in Fukushima. That would be very tough to politically put through. But this demand for energy and stable energy is in the U.S. especially so high that now we have these projects, which I think is very encouraging. But another thing that people think about is, or ask me about, is what is the individual impact, right? Of course, all of you, I assume, have seen ChatGPT or Midjourney, have created some images, and some people truly have a hard time, especially young people. They care about the world, they care about climate change, but they also want to have fun, so they use this AI, and then they feel bad, right? Like how much of an individual impact is there? And the simple answer is that if you're an individual consumer, the impact of using AI is fairly fine. It's just another tool. A typical query has lower energy consumption than running a light bulb for 5 minutes, or it's definitely much less than driving a few meters, just like meters, by a combustion powered car. So, especially if you use it for work and you boost your productivity and you do something productive with it, it's absolutely no reason to worry about it. It's just another tool that you need to do your work, just like you need heating, just like you need lighting, just like you need maybe an internet connection. So you don't need to worry about it. So the conundrum that I am focused on, and the researchers that are working on this with me, both on Stanford and in Prague, is that in this world, currently, with the energy sector trying to go through this sustainable transition, and this huge technology coming in with new that is AI, that has new kind of demands, we need to kind of find a balance between the challenges and the opportunities. So on the energy side, one of the challenges is we have an increased complexity from including more renewables, and also smart grids. And also we have this increasing power consumption that I've mentioned, right? So we need to kind of figure out a way to have enough plentiful energy to come by for all of these uses. But also there are very many opportunities in terms of how we can control the grid, how we can make the resources that we already have in the grid more efficient. And also, as I've mentioned, there's a great deal of opportunity in the investment that is going into AI, because energy is really becoming the next bottleneck in the development of this generation-defining technology. And that's exactly the job of researchers like myself, that we need to make sure that these opportunities outweigh these challenges. And we're working hard on this, and I think the progress has been very encouraging. So let's be more specific, and let's take a look at some of the ways that we've discovered that AI can actually help the sustainable energy transition. So those of you that are not familiar deeply with power grids, this is what they could be simplified as. You have the place of generation on the left. You have a step-up transformer that puts it into high voltage, basically. You have the transmission lines that get it to the broad centers of consumption, which are cities and industrial places. And then you have a step-down transformer that gets it to the individual consumers. And there are many different opportunities that we can explore, but I'm going to show you 3. There's powerful optimization on the part of the transmission and distribution lines. There's power demand forecasting, and then there's also consumption modeling. So powerful optimization, what does that mean, right? So this means that actually the power that we consume, that we have on the lights and the heating right now, it doesn't just appear from thin air, right? It has to be generated somewhere in some power plant, be it photovoltaics or a coal power plant. And we need to get that from the place of origin to the place of consumption. However, all of these power lines, all of these connections actually have physical boundaries in terms of how much power they can transport in any given time. And this is what in computer science is called an NP-hard problem, which means that even if you had the most powerful supercomputer in the world, it would take longer than is the lifespan of the universe to figure out this problem, which is a problem because in the energy grid, we need to solve this pretty much every couple of minutes. So we need to find clever solutions. And this is one of the ways that we have used AI for, because we can approximate this optimal solution to actually figure it out in seconds instead of, decades. And for example, when a power line falls, and we've had a small blackout here in this country a few months ago, we can adapt very, very quickly. Now, another use case is forecasting. So I've mentioned that the integration of renewables energy sources is a challenge. And a big reason for this is that at any given moment, we have to have an equation equal. So, and that it's basically a market equation. At any given moment, the demand for power has to equal the supply. Now, in the past, this was pretty easy, right? 50 years ago, we knew pretty much when the power will peak. It was one is in the morning and one is in the evening. And basically, when we need more power, we burn a little bit more coal. When we need less power, we burn a little bit less. We don't worry about it. But now with renewables, you have wind and you have solar. Unfortunately, these peaks do not really correspond to when the power is generated, right? Wind is very erratic, while at the same time, the solar power usually only is supplied during the day in most places. And so it is much more important for us to be clever about understanding where the demand is coming from so that we can balance out the grid. And at Stanford, in collaboration with North America's largest independent systems operator, which is called MISO, and with some technology from Meta, the parent company of Facebook, we've developed this technology called Neural Profit, which is an artificial intelligence-powered forecasting tool, which has helped MISO to really pinpoint not only where the demand will be what at any given point, but also why. So we have this kind of breakdown that you see in the middle in terms of what role does temperature play? What role does the fact that it's Monday play, etc.? And what role does the fact that this is primarily a suburban area, for example, play? And then the last project that I want to showcase and highlight is a little bit closer to home. That's why I've chosen it. You have this conundrum where, in order to decarbonize mobility, you of course need to adapt electric mobility, but also this affects the power systems, right? Because it's a higher consumption because all of the power that we've been using or all of the oil that we've been using to power our cars suddenly needs to come from electricity. Now, the wonderful thing about EVs, I'm a proud owner of an EV and I love it, but hopefully eventually you'll see the advantages of this technology. But the wonderful thing about EVs is that as they are a much simpler machine than combustion cars, and so with the economies of scale, they become more accessible, and of course they become better cars. And of course, they're quiet and no emissions. It's a bunch of things that you can love. So the ramp up, and you can see this even in Czech Republic, which is very EV skeptical, I think, traditionally. Right now, it's one of the fastest growing EV markets. And the reason is, of course, because it's cheaper, it's more accessible. And this will continue for quite some time, almost exponentially, right? But for EV power charging infrastructure, which is also very important, this is not the case, right? Because when you think about it, the same economies of scale doesn't apply, because when you're a developer of the infrastructure, first you will approach places where there is enough space for these chargers, where there is enough capacity in the transformers, where there are cables that can actually support this kind of power. And then once you use these up, you move to the harder and harder to reach places where, for example, in San Francisco, right now, if you want to install a new EV charger, just the bureaucracy will now take you more than 24 months. So you have to wait more than 2 years to install a new charger. It's pretty crazy. And you can see this kind of trend already developing in Czechia as well. So, while the EV registrations are still growing steadily, the number of installed chargers is dropping off a little bit, which might not be a huge issue, but it is showing some sort of signs of challenge. And so, therefore, what we need to make sure is that we put the chargers that we can actually build in the places that they are going to be used, or in the places that they are going to be useful for the grid in order to, for example, balance them out. And so what me and my lab have done is we've built on top of some research at Stanford or from some of my colleagues there that has shown that, okay, in public chargers, there's some behaviors, but in private chargers, there's some other behaviors. And we said, well, actually, depending on where you place the public chargers, and public chargers are more common here in Europe, the behavior also can change, right? So when you place a public charger that is near the airport, it's probably going to behave slightly different than near a park or near an office building. And we've been the first in the world to really show exactly how, right? And there's been some interesting patterns emerging that, for example, near the airport or near recreational areas, there's more charging in the morning. Nobody knew that before. We've shown that. And near some industrial areas, where you might have multiple, shifts, kind of exchanging at different time. You might have multiple peaks, right? So one peak in the morning, one peak in the evening. And we've been collaborating with the Prague distributor, which is Pre-Energetika, Predistribuce, excuse me, to help them inform kind of the placement of the new chargers. But essentially, the big goal for us is to bring the power grids, which is essentially a 19th century grid, into the 21st century, right? We now have new demands for our cities. We want them to be sustainable. We want them to be distributed. We want more freedom. We want more shared assets. We want to be communal. And that's all great. But of course, we have to work within the bounds of the infrastructure that's already there because we want to exploit it to its full extent. And again, as I said, this means also kind of breaking free from this very centralized view of, okay, we have this huge power plant that is usually running on fossil fuels, and we use it more or less based on the demand. And we have to make almost like a living organism out of our countries and cities that communicates among its different partners and different units based on the individual needs of the different nodes to of course, use the resources as efficiently as possible, but also to redistribute them based on market forces in times of need when some disruption happens in terms of a natural disaster or a wire falling down. And so this is exactly why we founded the LIMESS Lab and the Center for Energy Networks and Transportation between CTU in Prague and Stanford, because we believe that this topic is really generation defining. This connection of AI and modern technologies like vehicle to grid, and also sustainability specifically in power systems and transportation, and is also tragically understudied, right? Most engineers that understand AI, they would rather, or they usually go to the Googles, the Metas, to work on the tech issues that are just pushing the boundaries on the technological level, but they don't necessarily always think about how we can push society forward to a more sustainable future. And so we're opening up these opportunities in Prague and the wider Czech region, or even European region, so that these topics can be studied a little bit more. So I want to conclude very briefly to summarize what I've been talking about in this keynote. So firstly, abundant energy is the foundation of our well-being, and the challenge is really about making it green and how we can use AI to help. Second, Artificial intelligence already has a profound impact on the grid, even though individually it's negligible. You don't need to worry about using ChatGPT to answer some quick queries. And the opportunities, I strongly believe, outweigh the potential risks in the power systems context, at least. And then third, we must focus our efforts in applying AI to get the 19th century power grids that we kind of built in the past and we have to live with to the sustainable vision of the 21st century that we all share so that we can leave the planet a better place to future generations. And with that, I would like to thank you for your attention, and I look forward to connecting in case you're interested.